database system. When I learned the first time the database, I didn't know anything about the data, what is the information, even what is Oracle, what is the DBMS. I didn't know that. So I just started to study about the data, but fortunately when I learned the database the first time, it was 1996. I think that is 20 years ago. So I just graduated from my undergraduate program, then I majored in the mathematics. To understand the concept of database, there is the mathematics, the concept was very, very helpful, especially the set theory. So do you remember what did you learn in your elementary or the middle school about the set or set theory? Right? What is a set?
Collection of elements.
Connection of elements. It's a group of elements, right? It's a collection of elements, right? Then why do we need a set in mathematics? Have you ever thought about it? Relatively, in the math, set theory is quite easier than other subjects, right? So you learned a lot of algebra and geometry, equation, formula, theorem, but the set is relatively easier part. But actually it's much, much more important than the mathematics subject, the set theory. So what is a set? Why do we need the set when we learn the mathematics? Any idea? Why? The set theory, set. Why do we need the set in our mathematics? Just, it doesn't matter, okay? It's not math class, so just express your opinion, whatever, okay?
Oh, the database.
Oh no, you don't have to worry about the database. I'm just asking set theory or set the concept in mathematics, not the computer science.
To solve the problem.
To solve the problem of what? What kind of problem? Do not answer math problem.
Any problem that we see in our lives.
In our lives. It's too broad. What do you think? No idea? Even I didn't have any idea at the time. Anyone? Yes?
It makes easier to add or subtract or doing some...
Yes, that's another
To a
important
different
thing,
kind
the
of-
set operation. So we can combine, like the intersect or union. And
Yeah,
or
yeah,
minus.
different kind
There are
of
two
data.
different kind of group of
Group of
data,
data.
right? So, but when we start to define the set, what is the example of set in your math class?
A set of integers.
Integer is a set. And what else? Natural number.
Natural.
And
Whole number.
so rational number, irrational number, so a bunch of different number. That's the key point of the set theory. Unfortunately, we have infinite number in our math, in our life, in the universe. It's an infinite number. So when we define the operation like the plus, minus, or subtract, the times, how can we show a plus b is equal to b plus a? So you need to show all the number. Is it possible? No, definitely it's not possible because we have infinite number. So it doesn't make sense to use the certain operation for the infinite number. It's hard to prove, even sometimes impossible. So how can we define such an infinite number? At that time we can, instead of 1, 2, 3, 4, 5, 6, 7, 8, we can define group of the number as integer, something like that. What natural number? So using such a set concept, we can define, we can manipulate the infinite number. For example, natural number or integer number. Then we can do whatever we want, right? Think about the database. Why do we need the data and database? Because why?
Because we can have like a large amount of data.
Large amount. That's a key point. Okay? If we have small amount, even though that's a very important, it's critical. Like the password to start the nuclear bomb. Do we need to keep in the database system, Oracle database? No, you'd better memorize that password, right? So that's the reason that only the president knows the something secret number. We don't keep such a number. Okay? The main purpose of the using database or data, sometimes people confuse the main purpose of the data and database. Every time, every moment, while you are using the computer, you are using data. And also database, certain different types of the database. What about the cell phone? When I'm using cell phone, do I use the data or database? Yes, a certain type of the database. Mostly such a data are in the memory. It's a memory base. What about your simple program? Like when you learn the new program, you probably implement, compile, and run the Hello World program, Java or whatever. What about the database in this program? Do we use the data and database here? Yes, we are using memory database. So in your process, so when you compile and run the program, it creates a process. In the process, it has certain data structure. In the process, heap area, stack area. Do you remember the stack area? Store the temporary data, and the heap keep the data, and it has a text information. This heap, between heap and stack area, is your database. You can keep such a data. Like I define the integer I in your program, then this is your database and data. It's a very simple. It's enough. Why? Because it's a small. The problem happens when you have very large data and very large information, very large database. At that time, we need certain database. Then we borrow the idea of set. Using set, even we can define infinite number. We can just set, for example, x bar, x is bigger than 3, and x is an integer. So we can define certain number using the set. Okay? Similarly, we can define huge number. So suppose that we have the millions of student information. So for we instead of define integer 1, integer 1, integer 2, integer 3 for 1 million, why don't we define student something? Eventually there will be table or entity in our database concept. So we define. Okay? It's a group of data. Just like the set. A set is group of number. Okay, that's the main idea. Even though some of the professors do not realize why we are using database, where it coming from, really. Fortunately, I major in the math, so I can compare between the set theory and math, and then it was very easy to understand the main concept of the data. Because we have the very large data, even nowadays, the current DBMS relational database not enough to keep big data. You heard about the big data, so that's a little bit different story. We set aside at the end of the semester. Okay, we will a little bit talk about that problem, but still, so if you take a look at the first academic paper that proposed the relational model, whatever that is, you don't have to worry about what is a relational model, what is Oracle, but when they proposed the first time, they mentioned too many very large data. We proposed ABC or certain database model. That is the relational database model. How idea is, why don't we keep the only common thing? So name, ID, and address from student 1. Name, ID, address, name, ID. Same name, ID, and address, and group of name, ID, and address. We have the same format for each element in terms of a set. Okay? Set theory. Then grouping. Then we can easily manage. And when we search the data, it's very fast, such a data, because they have the certain model. It's a template, so it's not very difficult to find the specific, student or element. That's the idea of database system. Do not forget such an idea. So whenever we learn something modeling or query processing, was even SQL. So all these application and idea and algorithm are based on such a basic concept of the database. It's a group of data. However, that's a little bit different from what you learned in your programming class. So which programming are you using in your core course? Object-oriented programming, OP course, right? Is it based on the something relational or the network or whatever? What kind of model you use? Object model. Okay. Object, in terms of object-oriented model, how do they regard the data? How? What is the data in object-oriented model? It's an object, right? Everything you consider the data as an object, right? Then you can initiate the student object, then you can have the instances. And also, using that such an existing student, we can also have something inherit. We can inherit the characteristic of the student, so graduate student and undergraduate student, good student, bad student, okay? Something like that. So that's the way of object-oriented programming. So we regard the data as an object in object-oriented concept. However, unfortunately, in the database area, in this class and still in the market, they use a different model. So in the programming level or the software engineering model, object-oriented concept, object-oriented model is popular, some majority. However, in the database, which one? There uses object-oriented model, but the majority is relational model that we are going to learn in this class. This relational model consider data as a set, group of the data. This one is not group of data. We consider something objects. That's the key point of the object-oriented. That's the huge difference. Because of that, it causes a lot of problem also. Okay? Because of that, it's not flexible. Think about I limit the student as what? Name, ID, address. Name, ID, address. But he has more valuable information like he has the experience on database. We cannot keep such a data. Also, other student from the other country has a different background. But because of the definition of the student, I can keep only name, ID, and address only. We cannot keep other information. It's not flexible. It's not customized. Also, when we consider the data in terms of the object-oriented model, so student, we can define something, the person object. Then from the person object, we can also create the faculty, the staff, student, because all of them are persons. And for the student, we can specialize. So we can use such a concept, object-oriented concept. On the other hand, the database relational model, no, we cannot do that because we fixed. Okay? So why don't you keep such a difference throughout the semester, try to understand what is the characteristic of such a relational model, database model, then how can we overcome when we are working with the other program languages, that will be helpful when we learn about the database concept like the query optimizing and the transaction management and so on. Okay? Any question? So these are the basic definitions that we already discussed. So quickly, so this is database is a collection of the related data. So related means same format, right? Student, we are not going to keep the faculty information in student set, student table, student database. Okay, only student, they are related. So, however, so when we are saying the relational database model, the relation does not directly means the related. Okay? Instead, relation means more like definition of the database concept. That means the set, group of data. That group of data should be related, okay? So that is a relational model. Then we already discussed of the data. So our goal is to build a database and the database system for the such a real world information. Then, what is the impact of using the database? It's everywhere nowadays. We use the database for the business, the system, and the service industry, education, and even personalized device, the mobile device, such as the smartphone. We use such a database system, small database system. Okay, but main problem of the current technology on the database system is in terms of the size. What is the thousand of the terabyte? So currently, many of the people are using terabyte level, the hard disk drive for the laptop. Mine is the 256 gigabyte. It's not the hard disk drive. It's a solid disk drive. So it's even still expensive. But many of the laptop has something terabyte, right? 1 terabyte or 2 terabyte. Then what is the 1,000 terabyte? It's called gigabyte, next terabyte, next petabyte. So what is the next? Zettabyte and exabyte. Okay? So petabyte size level is enough for the current database technology, especially relational databases. So that's enough for the most of the company. There are not many companies. Their total size is bigger than 1,000 exabyte. But nowadays there it is, like the Google, Facebook, YouTube, and Twitter. Their database total database size is above petabyte size, exabyte level. So database, for example, Oracle, Informix, DB2, such an existing relational database model can support up to the petabyte size level, but not enough for this. Because of that, we need to think about a different database model that is called NoSQL database. But this is beyond the curriculum. So if you are interested in this part, I'm going to offer the NoSQL database course next semester. But so this will be used for the current application and the system. So this is an overview of the database system. What if we do not have the DBMS software? This the box. Is it okay? Yes, it's okay. So many of the systems actually do not use such a database system. In case you have very large data to be managed, then we can put the DBMS part, database software, to keep such a very large data. What if we do not have the database? How we can manage the data? File system. We can use a file. Even sometimes a file system is faster than DBMS. Why? Because we pay a lot for the Oracle database. Then why Oracle is slower than file system?
Depends on the size of the data. If the data is small, file is much faster than data.
Think about the basic. This is a file system approach. This is the database approach. When you manage your data, like me, I'm using Notepad, lee.txt file. Keep all the data in the file. Okay? I'm using Oracle database. So this is Oracle to manage the same data. How can you use this plain text file as a database? In your program, you can open the file, then read the data using fopen or open the file, whatever the command API you use. Open the file and read the data. Whenever you find the data you want, then return or process. What about this one? You need to install running the Oracle database, it needs a huge amount of the memory size and the process requirement that connect the Oracle database from your application, and this database is run is too much overhead. Okay, so basically, file system approach is faster because it's low level. Then why do we use this? Because we have the very large data. When you have the very large data, this is more convenient and faster. I don't say that this is exact, always faster. This one is faster than this one, but mostly the database approach requires a lot of overhead. Then how can we overcome such an overhead in the database system? One way, index. We can use index. It's like the index part of your textbook. There's a sorted data keyword. Then, just like that, we can use the indexing technique to speed up. So we will learn about the indexing structure, second part of this lesson. Okay? Also, your project will implement specialized indexing structure. It's called the index organized table. Then second, another way to improve the performance of the database system is name. What about the think about why don't you think about the general computing architecture? How can we speed up usually when you use the data? Any idea? Still sleepy?
It's, maybe we deal with the memory.
Memory. Very nice. Let me know when at the end of the semester I will give the extra point. If you are doing very well for your project. Memory. Always, whenever we encounter speed problem in the computing architecture, we use the memory, cache a lot. Okay? Even there is a cache in the CPU, L2 cache, layer 2 cache, and whenever the database, even hard disk drive has the cache, memory, its own memory. So actually DBMS system, database management system, use a lot of memory as a cache. For example, Oracle, when you install the Oracle, it is recommended to use half of the all physical memory. For example, if you have the 16 gigabyte memory in your the database server, half of them should be the reserved for Oracle database cache. Really, sometimes 2/3. Okay, so we will see how we can increase the performance using the memory. Okay, that is a proper management. So this is the database. So we will use such a database software for this purpose. Okay, so this is an overview of that. Okay, then you will, so in your project A, we will use the Oracle database. Okay, install the UB. You don't have to install the Oracle server on your laptop or computer. You are going to remotely connect. Then from your application program, you can use any program language. If you are familiar with .NET, yes, you can use a .NET program. If you try to use Java, you can use Java. Some of the students prefer the low-level language like the C language. So you can use the C language. I have seen only one of the students in my experience to use a COBOL. Do you know what is a COBOL language? It's all the language still used. So sometimes the company are looking for expertise on the COBOL because their old system is based on the COBOL, but it's very hard to find such an expertise. So why don't you try to learn? It's not very difficult. It's sometimes easier than the other, but you don't know.
That makes sense.
So especially the Y2K, when the year changes from the 1999 to the 2000, the people are crazy. I'm not sure whether you guys remember the Y2K issues. Okay? At the time, many of the companies would like to hire who know the COBOL language because COBOL is a serious They said it was a serious problem, maybe serious, so nuclear weapon will be exploded or whatever, but was not that serious. But anyway, at the time, many of the expertise on old-fashioned languages moved to the job. Okay, so this is the what. So program language, there is no limitation. So from the program, your own program language, connect the database system to get the data. Okay, this data is stored in your the hard disk drive. Sometimes it's organized by the DBMS system. It's not like the file system in your operating system. Okay, even though this software is using your file system. Okay. Any question? So, what kind of benefit we can get from the DBMS? What kind of utility, what functionality we can use? So, definitely we can define. So, to use such a set, this is a set, so we define the very large data as a set, which means a relation. Okay, this relation, this whatever that is, should be defined in your database system. Okay, so that's called the database model. Database should be model. It's a structure or standardized. So that is a database model. There are a bunch of different ways of database model. I already gave you the one example, object-oriented model, the database model. You consider data as object. What else?
Hierarchical model.
Hierarchical model. So you can consider data as hierarchical, like this. This is my first database model that I use. When I learned something programming, whatever, it's a hierarchical HDB in IBM. So, bank, there's a bank, and as a branch, there's a branch. Branch 1, branch 2, each branch has customer saving account, and loan account, and credit card information, and branch 2 has subscribing. Benefit? Very fast to access the data. Because it's next, so which is called get next. You can use get next operation, find the next, then finally easily find the data. Problem? Memory?
Overhead memory. Because if it is more entities.
Anyway, this structure will be stored at the hard disk drive. So memory is not the direct problem. Memory can be problem when we search the all customer information. Like I'd like to get the average balance, all bank. How can you access the data? Customer, the saving account is branch 1. Go to here. Another saving account. Go to here. Go to here. So you need to visit all the descendants. Takes a long time. You need to keep all the data in the memory until you find it. So this is one of the examples of the network model. And what else? Hierarchical model and network model. So we can use some relationship between the data and represent such a relationship as a network. So network database model is possible. So no matter what types of model you use, so your data should be defined in your model. In relational model, we will consider data as a group. Such a group will be defined. Eventually that defined model will be what? Table. So you are going to create the table. I know some of you guys already have an experience on the using relational database, like the MySQL or SQL Server or the Oracle. At that time you create the table, right? And select the data. So create table. Table means define your data. And construct, okay? More important thing is the manipulation. After you create the define and the construct the data, it should be able to retrieve, okay, or modify. So database model, DBMS provides such a functionality, and plus many other things. So that we are going to discuss throughout the semester. So this is our goal to develop. We'd like to develop such a database. Okay? How can we? So this is an example of the what? University. Okay? So we want to build such a university database. At the time, it has, so in terms of the database model, so that I explained, for example, set. This is one set of data, courses. And this is one set of the data section. This is another set of data, another set, and the student set. Right? Then we can make the group of the data. Eventually, we will call each one as the entity, or sometimes it's called the relation. Eventually, it looks like the table, so these are called as the table. But anyway, this is our goal of the class. To do that, we need to first do what? We need to understand the data. In this case, the university sample of the database in university is simple. Everybody knows it has the student information, faculty information, grading section, and so we can easily group such a data. But in real world example, like when you build a database for the NASDAQ, okay, stock market trading system, you should know all the business flow, right? If you build a database for the Google, so you need to know how the Google is organized and how it works. So you should be expertise on your database. It's the same thing. When you are doing the project A, you should know, you should be the expertise on your database. Then find any characteristic, any relationship that we can make the course information, because it can be group or the entity. And group, then find such a thing. And also we can find a relationship. For example, student take the course. That should be reflected in your database design. That is called database design. So first we are going to focus on how to design, how to organize the data. From where? Information. From information, this is the information, then make the something model. This is called data model. Data model is a very high level design. So it doesn't require any specific skill in computer science, no programming. So for example, when you design, when you organize your room, okay? If you go to my room, there are a bunch of the paper and handout and the sketch paper. So when I organize my room, do I need a computer science skill? No, we don't need. Instead, you should know which one is which, right? So I need the database, the paper, then grouping. I need the operating system, the paper or material, and grouping, and file.